Hello everyone and welcome back again to another new video of DeltaMind. Today in this video, we will be moving to our next destination of our complex analysis journey, which is complex functions. Well, in our previous videos, we have already covered imaginary numbers and complex numbers, which I am assuming that you already have watched or you have some prior knowledge of complex numbers. So let's get started with the most fundamental question. What are complex functions? Well, simply a complex function is a function that takes a complex number as input and produces a complex number as an output. Well, a complex number f of z is a rule that assigns a number w, which is a complex number, to every complex number z in its domain. Or to be more simple, it simply takes a complex number z, applies a rule in it and produces another complex number w. It is denoted as w equals to f of z. As you already know, in the real functions, we write y equals to f of x. It is quite similar to that. But we already know that in real valued function, both the variables x and y are one-dimensional numbers, so that we can plot them in a two-dimensional graph. But in the case of complex function, both input and outputs are two-dimensional. So if we try to plot them together like we plot the real functions, it would become a four-dimensional graph. But we essentially cannot graph a four-dimensional function. So we write the complex function f of z into its real and imaginary parts. F of z equals to u of x comma y plus v of x comma y times I. Here v of x comma y is the imaginary part and u of x comma y is the real part. And now we have decomposed our function into two independent functions, which we can graph separately. For example, let's consider the function f of z equals to z squared. If we wanted to decompose this function into its real and imaginary parts, we would first need to substitute z equals to x plus iy. So f of x plus iy equals to x plus iy whole squared, which if we expanded would give us x squared minus y squared plus 2xy times I. Here its real part is x squared minus y squared and its imaginary part is 2xy. So decomposing functions are a crucial step in complex analysis. Whatever you do, whether it's applying a theorem or performing contour integrals, decomposing functions is a must. So that's everything you needed to know about complex functions. In our next video, we will discuss about complex limits and differentiability. Meet you in the next video. Until that time, bye.